Hi, and welcome to the first day of our factoring review for our pre-calculus or squeeze class. Today we're going to go through a little bit of factoring. Now, just a little reminder of what factoring is when we're multiplying two binomials together, say x plus 2 times x plus 3, what we do to expand them is to FOIL. So x times x is x squared, 2 times x is 2x, x times 3 is 3x, and 2 times 3 is 6. So as we combine those, we have x squared plus 5x plus 6. Now when we go from the factors to this way, we say we're foiling or expanding. And when we go back the other way, it's factoring. Now, factoring, to get away from the algebra, if we factor whole numbers, say if I want to factor 8's not a good one. Let's do 12. I can break 12 into factors. We can say it's 6 times 2, and 6 can be 3 times 2, so 12 is 3 times 2 times 2, and these are all factors of 12. Now this 3 times 2 times 2, we call it the prime factorization of 12 because all of these numbers are prime numbers. When we're factoring polynomials or quadratics, this is a quadratic because its highest exponent is x squared. When we factor this, what our goal is to get linear factors. So it's linear because each of these, if we had y equals this or y equals this, they would both form lines. So we call these linear factors. So that's our goal when we're factoring. Now, the first step whenever we factor a problem, so if we look at this problem and want to factor it, the first thing we have to do is see what's in common in each of the terms. There's no number in common that I can divide out of all three of these numbers, but there is one t. So I could take a t out, and then that first term would be 3t to the third plus 5t squared plus 7. Now we have to look at this and see if we can factor this any further, and we can't. There's nothing that would factor this further, so we're done. Now in this one, let's look at the numbers 3, 9, and 15. What can factor, what's the biggest factor that can come out of each of them? Hopefully you're all screaming 3. 3 is correct. And now we look at our s's. There's 4 s's, 2 s's, and now 1 s. So 1 is the largest I can take out of all of them. And t, we can't take out a t because this one does not have a t. So 3s to the fourth divided by 3s would just be s to the third minus 3s squared because I took an s out. Now the t's stay the same. And then I took a 5 out, so it'd be 5. The s goes away, and we're left with a t. All right. So you guys pause your video, try this one, and see how you do. All right. Hopefully you're all done with the problem. The biggest number I can take out of each of them is a 3. I can take out an x squared, and I can take out a y squared, leaving 2x, and that's it, on the left-hand side. And then here it becomes 5 and y to the third power. All right, look at that. We're already done. Hopefully everybody got it right, and you're all proud of yourself. And then we get to this problem. This one's much different than these problems because all of these ones had something you can take out. When you get here, there's not an x in every term. There's not a coefficient we can divide out of each term. So this is called a trinomial because it has 3 parts. And when we're factoring trinomials that are quadratics, we want, we're doing the opposite of foiling. All right, so the first thing we have to think about is what two things can multiply to get an x squared? And the answer is x times x gives us x squared. What two things can we use to multiply to get to 6? Well, I can do 1 times 6, and I can do 2 times 3. Now we have to think about this middle term. Which of these two will add up to being 5? So what I generally do is I set something up like this. It's two numbers that multiply to 6 and add to get to 5. So if I did 1 and 6, those do not add up to 5, so we can scratch them out. What about 2 and 3? Do those add up to get to 5? Yep. Do they multiply to get to 6? Yep. So that looks like it's going to work. X plus 2 times x plus 3. And if you're doubting yourself to see if uh, you think that that might not be right, you can FOIL it. X times x is x squared. 2 times x is 2x. X times 3 is 3x. And 2 times 3 is 6. So we have x squared plus 5x plus 6. So we know we did it right. So that's your answer. All right. Now try this one on your own. Pause the video. All right, you're looking for two numbers that multiply to get to negative 18, and they add up to plus 3. So 18, we can do 1 and 18. There's no way we can get to 3 from that. 2 and 9, no way we can get to 3 from that. There is 3 and 6. There's some options here because these multiply to 18, and 6 minus 3 would give us 3. And since this is a negative 18, one of these two have to be negative. So if we just put a negative 3 there, 6 plus negative 3 is 3. 6 times negative 3 is 18. So v minus 3 times v plus 6 should be the correct factors. All right, try this one again on your own. Pause the video. We're looking for two numbers that multiply to negative 24 and add up to 5. So we can do 1 and 24. No way we can add or subtract to get to 5. 2 and 12, not an option. 3 and 8, that one's looking good. If I take 8 and a negative 3, that will add up to 5 and multiply to negative 24. So x minus 3, x plus 8. All right, w squared minus 49. People with a lot of experience with factoring will just shout out the answer, and they think it's easy. And it is easy once you understand the shortcut. However, if you don't know the answer right when we start, we have to pretend like there is a 0w here. So we have a negative 49, and it adds up to 0. So 49, well, we have 1 and 49, which of course can't add or subtract to 0. But 7 and 7 can, if one is positive and one is negative. So we have w minus 7 and w plus 7. That should be a plus. Looks a little weird. All right, so this is our factor. Now, there's a shortcut. If we have w squared minus some square number, we can just square root that and then put a plus and a minus, and that should be our answer. So if I have t squared minus, I don't know, 81, it should be t plus 9, t minus 9. If I have p squared minus 144, p plus 12, p minus 12. Now, if I want to use that same shortcut here, we can use it. We just have to think about this 4w squared. We have to take the square root of that too. So 2w and 2w, and this one will be 4 and 4. One of them will be plus, and one of them will be negative, or addition and subtraction, and then we're done. Because 2w times 2w is 4w squared. The inside would give you us positive 8w. The outside would give us negative 8w, which cancels out, and then there's negative 16. 36s minus 1. Can you pause the video and write down the answer? This would be 6s plus 1 and then 6s minus 1 using our shortcut. taking the square root and doing an addition and subtraction sign. All right, now we get into problems that are a little bit more difficult. So what makes these difficult is there is a number in front of our t squared. There's a 15 there. 15t squared plus 14t plus 3. Now I'm going to show you two different methods for solving this. The first method is just guess and check. Some people love this method and some people hate it. So if I guess and check here, I've got to think of two things that will multiply to get to 15t squared. Well, I could do 1t and 15t. I could do 15t and 1t. And then I could do 3t and 5t, or 5t and 3t. And then here I could do 1 and 3, or 3 and 1. So there are a lot of different options. We just have to guess and check until we find one where the middle term adds up to 14. So let's do 1t plus 1, 15t plus 3. So that would be, this would be 15t squared. This would be 15t plus 3t, so that'll be 18t in the middle. We know that's not going to work, so let's erase that. Let's flip this around, so now it would be 3 and 1. So this would be 45t plus 1t. That's way off. Erase it. And let's erase our first numbers too. So 1 and 15 won't work. Let's try the 3 and the 5. So if I do 3t and 5t, let's do a 1 and a 3. So here we have 5t, oh, and that's 9t. So 5 plus 9, that's 14. And look at it, that's the answer. Wonderful. That's your guess and check method. Some people will love it. They'll think it's a great method. Wonderful. And you can use that as long as it works. Now, there's another method that's called splitting the middle term. It's got a process. A lot of people like this because it does have a process and there's not as much guessing and checking. The first thing you have to do is multiply 15 times 3 to get to 45. And then we take this number 14 and we put it here. So what multiplies to 45 and adds up to 14? Hopefully everybody is saying, well, we can do 1 and 45. That's obviously not it. 5 and 9 is an obvious choice because they add up to 14, multiply to 45. So now I want to split my middle term with these two values. So I'm going to write this again. 15t squared plus 14t plus, that looks more like t, plus 3. Now I'm going to split this 14t into two different sections. It's going to be 5t and 9t. Now that's kind of weird. We just took it and split this up. Notice that this statement is equivalent to this. The only thing I did is I wrote a 5t plus 9t, and that, of course, that equals 14t. Now what we do is we take this and we split this down the middle. So now I want to just factor out whatever I can from these first two terms. So I can take out a 5t from them. And what will be left over here is 3t plus 1. What I can take over here, I can take out a plus 3, and I'll also have 3t plus 1. Now here's where it gets a little confusing. Now from here, I can factor out a 3t plus 1. If I factor out a 3t plus 1 from both of these sides, I have a 3t plus 1 on the outside. And if I cover this up and cover this up, what's left over is a 5t plus 3. And look at that answer is the same answer that we have over here. All right. Now try this one. Pause the video and see how you do. All right. Hopefully everybody's paused the video and solved this one on their own. I'll do the guess and check first. So if I did 2 S and S. Let's try a 1 and a 6. This would be 12 plus 1. That's not going to work. What about a 6 and a 1? That's 6 plus 2. That's not going to work. So I'll have to do a 2 and a 3. So this is 6 plus 2. Now that's not going to work. This one looks good because it'll be 3s plus 2 plus 4s. All right, so 2s plus 3, s plus 2 is the correct answer. Great. That's guess and check. Let's try to split the middle term. So the first thing I do in splitting the middle term is I do 2 times 6, which is 12. What two numbers multiply to 12 and add up to 7? Hopefully everybody's saying 3 and 4. So I have 2s squared plus 3s plus 4s plus 6. Now I divide it down the middle and see what I can factor out of the first two. The only thing I can factor out is an s, leaving over 2s plus 3. The only thing I can factor out here is a 2, leaving 2s plus 3. And now these 2s plus 3's can factor out of the equation, leaving 2s plus 3 on the outside and s plus 2 left over. It's s plus 2. Look, I hope you can see that we got the same answer from guess and check or the method. Splitting the middle term, whatever you like the best could work for you. It's best to know both of them because sometimes problems get more difficult and guessing and checking can take a long time. All right, factor this, pause the video, and see how well you do. Here we have 15 times 4, which is 60. What multiplies to 60 and adds to 23? Well, there's 1 and 60, which is obviously not working. 2 and 30. That one looks pretty good. So let's divide it up. 15d squared plus 2d. Oh, 2 and 30 definitely doesn't work. What am I thinking? Hopefully you guys are yelling at the screen. That's 23, not 32. I'm dyslexic today, I guess. Let's go one more. 3 and 20. Oh, look at that one. That one's the one I'm looking for because those add up to 23. All right, so it's going to be 3d plus 20d plus 4. Divide this down the middle. What I can take out of those two sides is 3d, leaving over 5d plus 1. Over here, I can take out a 4, leaving again 5d plus 1. When I factor out that 5d plus 1 on both sides, I'm left over with 3d plus 4. All right, hopefully that method makes sense. Let's stop there for the day, and your factoring worksheet looks like this. I want to see you all get through number 16 for tonight's homework. All right, good luck.